Hello everyone, welcome to our channel Nursery to Varsity. It is an initiative to enlighten the global public with the knowledge of several miscellaneous fields. I am one of the members of Nursery to Varsity, and in this series of channel I am going to discuss logic in computer science. So let's start. We are discussing the concept of logic in computer science to know how information is captured in a sentence and how to possible for one statement to be the outcome for the other one. As we discussed that logic is used to design the digital circuit and knowledge representation is based on the logic formalism. But here the point of discussion is how this propositional logic is work for AI. The propositional logic is used in AI for the planning, problem solving and the intelligent control, and most importantly for decision making. It deals in a Boolean function, or we can say 0 or 1 fashion for some certain outcome. So propositional logic in AI, one of the many way how knowledge is represented to a machine so that automatically learning capacity can be enhanced. The ability of automatic learning is possible if our machine can interpret the information of our real world in right manner. And we know the machine are unable to understand our own language. As we discussed that's why only we fail to deal in natural language and we have to move toward the formal languages. So the knowledge of the real world environment need to represent to the machine in right manner that is readable to a machine, or we can say understandable by the computer. So our formal languages are two types we read in our last tutorial. One is propositional, second one first order logic, and this propositional logic is one of the simplest and easiest way of knowledge representation to a machine. So this is the part how our PL is work for AI. Now here I am going to discuss few basic definition about the propositional logic. So as suggested, it is the simplest and abstract logic we can study is called a propositional logic, or we can say it is a technique of knowledge representation in logical or mathematical form. So, and we discussed that it is also called Boolean logic as it work for 0 or 1 form. A propositional is a statement that can be either true or false. It must be one, not both. And we assign the value capital T if the statement is true, and we assign the value capital F if the statement is false. So this true and false value is assigned. So we can conclude as a statement or a proposition is a declarative sentence that is either true or false, but not both. If the statement is true, we are assigning a value capital T to it, and if false, then we are assigning a value capital F to it. So this is the assignment of the statement, or we can say the statement can be true or false. So here is example. I am showing you example that Rajasthan is in India. Is this true or false? So we can say this is true. Rajasthan is in India, it's true. If we talk about 3 plus 4 is 7, then again it's true. So if it's true, we can say it's proposition. Modi is Prime Minister of India, it's again true statement, it can be proposition. But do your homework. It's not a statement or declarative sentence, it's a command. So it's not a proposition. Jaipur is a state, it's a false statement. So these are the example of proposition. Now we have to discuss about propositional variable. So propositional variable in logic, it is required to draw conclusion from the given assumptions or given statements. Instead of writing the statement repeatedly, we abbreviate them by using propositional variable, and these variables denoted by a lowercase English statement P, Q, R, A, B, C as per their own ease. So here we can say our variable can represent a statement that P is denoted by Jaipur is a capital of Rajasthan. So Jaipur is capital of Rajasthan can be denoted by P in further calculation. Now we have to discuss about the syntax of proposition. So instead of saying syntax, we can say we have two types of proposition. One is atomic, one is compound. In atomic sentence, we can say the statement of proposition which does not contain any connective is called atomic statement or prime statement. And the example for this one single statement 2 plus 2 is 4. This is true and this is atomic proposition, and sun is hot. This is again a true statement, or we can say this is a atomic proposition. And if we talk about the compound statement or compound proposition, the statement of proposition variable can be combined by means of logical connective or operators to form a single statement called compound proposition or compound statement. So the example for this, it is raining and we are using and here. It is raining and roads are wet. So this is the example for atomic and compound proposition. And for moving further, we have to discuss about the logical connectives. So generally in the use there are 5 logical connectives which are going to frequently used for this purpose. So our table says that the first connective is not, and we can represent this symbol as, and the technical name for this connective or operator is not, and the second symbol is that is and it's called as conjunction, and we can represent P and Q. The third connective is or, we can technically say this a disjunction, and P or Q. The sixth statement is for implication. A symbol of implication is like this. We can write the implication and P implies Q. And the fifth is bidirectional or biconditional statement. We can, the connective is called if and only if, and we can represent in example as P bidirectional Q. So this is about the logical connective. So in this video we have discussed why propositional logic is used in AI. The reason of using propositional logic to AI is we have to make understand the machines or computer in their readable form, and they can read only 0 and 1. That's why we are saying that this is a type of declarative sentence. We are dealing with true or false, or we can say it's a Boolean logic which deal in 0 or 1. So this is the use of propositional logic, and we have discussed about the syntax, that is atomic and compound, and 5 connectives in this lecture. Thank you. This is all for today's lecture. Hope you have enjoyed this lecture. You can also follow us on Twitter, Facebook, LinkedIn, Instagram. You can see the links here. And don't forget to press the bell icon to stay updated. Thanks for watching. Stay tuned. Keep learning.